practical problem based on volume and speed. So let me explain the problem, what exactly the problem is. In this video, a practical problem is taken. In a village, the local authorities are informed that there is not sufficient water in the village water reservoir to suffice for the whole village for the next day. The authorities decide to pump water from the nearby village. The engineer is called and asked to make the necessary arrangement to pump water from the river into the reservoir. The engineer inspects the available resources, quantity of water to be filled to suffice the whole village. He finds that the water level should increase by 2.44 meters. They have a square pipe of size 20 centimeters and he has to pump the required quantity of water in 18 hours. To solve the problem, he calculates the speed at which water must be pumped. This is the problem. Okay. Now, if you have to solve this problem, if you are asking this as a question, if you put it, how will this be asked? A cylindrical reservoir is 120 meters in and 75 meters high. At what speed per hour must water flow into it through a square pipe of 20 centimeters wide so that the water rises by 2.4 meters in 18 hours? So if you put this problem in the form of a question, the question will be in this form. So you get an idea. So now, if this is a thing, let us see how the reservoir looks. This is how the reservoir looks. Clear? Now, what is the shape of the reservoir? The reservoir is in the shape of a cylinder. If it's a cylinder, then the diameter of the cylinder is given as 120 meters. So then radius of reservoir is 120 divided by 2. Half of the radius diameter, that is 60 meters. Height of the reservoir is 75 meters. But we are not going to fill the entire tank of 75 meters. Height of water required to be filled in the reservoir is only 2.4 meters. We are not filling the entire 75 meters. There is some water already in the thing. We need to add another 2.4 meters of height of water. The volume of water needed to be filled will be, since it's a cylinder, the volume is given by the formula pi r square h. Okay, pi r square h. So let's put the value. Pi is 3.14, r is 60, so 60 square into 2.4. So 60 square means 60 into 60. So that will be 3.14 into 3600 into 2.4. If you multiply all this, you get the answer 27,129.6 meter cube. This is the volume of water that must be filled or pumped into the reservoir. So we must fill the required volume of water in the reservoir in 18 hours because time is allotted. We have got only 18 hours to complete our work. So volume of water in 1 hour will be this volume divided by 18. That is 27,129.6 divided by 18. That is 1,507.2 meter cube of water to be filled in 1 hour. Clear? Now let us see. So every hour the pipe must deliver 1507.2 cubic meters of water. If that is the quantity to be delivered, the pipe is a square pipe of size 20 centimeters. Since the pipe is only 20 centimeter, so and we are calculating everything in meters, so we divide this by 100, it becomes 0.2 meters. The cross-section area of the pipe will be side into side. That is 0.2 into 0.2, that is 0.04 meters square. Clear? Rate of flow of water per hour should be area of cross-section into speed. Rate of flow of water is how much? 1507.2. Area of cross section is 0.04 into speed. So speed will be this divided by this. Speed is equal to 1507.2 divided by 0.04. That is 37,680 meters per hour. This should be the speed at which water must be pumped into the reservoir. But we know that 1 hour is 1600 seconds. So if you calculate this speed in seconds, so speed will be 37,680 divided by 3,600, that is 10.5 meters per second. This much be the water that must be pumped in at meters per second, or also 1 kilometer is 1000 meters. So if you calculate in kilometers, so speed will be 37,680 divided by 1000, that is 37.68 kilometers per hour should be the speed at which water must flow into the reservoir. So we can say that water must flow through the pipe at 37,680 meters per hour, or about 10.5 meters per second, or 37.68 kilometers per hour for the reservoir to for the water in the reservoir to rise by 2.4 meters in 18 hours. Clear? Now, problems you can try. I've given you four problems here. See, this is one, this is the second, this is the third, this is the fourth. You can try this on the similar lines. You get an idea how we are calculating, and these all are practical problems which happens. See, this is in a fountain. This in the first question is about a park fountain, water fountain is a rectangular field in a swimming pool or a tank. So this how we use this mathematics concept of volume and speed in daily practical ways. Okay, so thank you for watching. I think you are clear it is.